thing we're going to look at is yesterday, it just goes back to this graphing. And I'm going to start with the VT graph. So let's look at that question again on page 69 because it's going to end up essentially setting up what I want to get to today. So I'm just taking the first part of that graph. And on a velocity time graph, if I find the slope of this line, what does the slope of that line give me?
Velocity.
Nope.
Acceleration.
Acceleration in this one. If it was a DT graph, it would give you the velocity, right? But on this one, it gives you the acceleration, right? Oops. Gives you the acceleration. Because it's the change in y over the change in x. In this case, your change in y is your change in velocity, and your x is your change in your time, right? So we've got a is equal to change in v over change in t. All right. Now, so by finding the slope, we can get the acceleration. What did I gain from finding the area under the graph? What did I find there? Distance traveled. Okay? Or in this case, it could be displacement because I'm still using vector quantities for each of them. But it is your distance traveled. So when we looked at it, we found in section A, we were able to find the acceleration. We were able to find this distance. I think this distance was 15 meters, correct?
Yep.
Right? Because it went from 0 to, is this 15 meters per second? So that's 15 meters per second. And in second section then, we had a time of 3 seconds. 3 seconds right here in this section. So I'm going at a constant speed of 15 meters per second for 3 seconds. Fair enough? Okay, so that gives me a total of 45 meters. Still moving away from where I started because it's on the positive side of the velocity. Once it goes to the negative side of the velocity, then that means that I'm actually changed my directions. It doesn't mean I'm slowing down, it means I've changed my directions. So is everybody okay and comfortable with this from yesterday? Okay, we're going to work on some questions with it today, but I just need you comfortable with it because I'm about to show you how we get our equations. I'm going to give you 5 equations today. Those are the 5 equations that you will use for 2 straight years in this class and are necessary to know how to use. You will always be given them on a formula sheet, okay? But you need to know how to use those effectively. So I'm going to show you where they come from today, and you're going to take them down and we'll work through them. Fair enough? Okay. Just need your book for a second. Okay, so the start of this comes from here. So what I'm going to get you to do right now is take out a blank piece of paper. And we're going to put this in big block letters like you just learned to print in grade 3. So that you have 5 equations. So you can list it 1 to 5, nice big numbers so you have it beside you. We want this beside you so that you have it to look at every time you do a question. Okay? This is not equation number 1, so don't put it down here. Equation number 1 comes from this equation. Change in velocity is found by taking v2 minus v1. We agree? Over time. Okay? So therefore, acceleration is equal to v2 minus v1 over time. If I wanted to find out what my second velocity was, how do I solve for v2 here? What's the first thing I need to do to get it by itself?
Add v1 to the other side.
Not yet.
Get rid of the time.
So what do I do with the time? Multiply it to the other side. So I'm going to multiply that up to the other side. So that gives me a delta t is equal to v2 minus v1. Now what's the next step, Casey? Now I add v1. Equation number 1 for you. v2 is equal to v1 plus a delta t. All right? This is not a brand new equation for you. All I did was manipulate the original equation, which was A equals change in velocity over change in time. Right? The second one, we don't use often.
Oh, I do.
Here, let me do this.
I can just get them, Sharon.
There we go. Okay? The second one is to find your displacement given your two velocities, given your initial and your final velocity. Now, we don't use this often because generally you have an acceleration. When you're changing from V1 to V2, you're going to have an acceleration of some sort. So we usually only use this when we don't have acceleration given to us. So to find your second one, that is to find your displacement, you add your two velocities together and average them times your time. So here's equation number 2. Add your two velocities together, divide by 2 times your time. Now this is very rarely used. And not only that, I prefer not to use it when we get into vectors, and you'll see why. Because I want to find out all my individual displacements and then put it together. Okay? The third one, all right, comes from this right here. So I take a graph, a VT graph, delta V, delta T. And I draw a line which represents an acceleration, right, through my slope, because I'm changing my velocity over a given amount of time. Everybody follow this so far? Okay. How did I find my displacement on that graph?
You found the area.
The area under the graph. We all agree? Found the area under the graph. So in the first case, the area was a shape of a, in the second case, it was a rectangle. 3 of 15 does not make a square for the record, but you're right. 4-sided figure. So here's how it goes. Okay, so we all agree with that, right? Well, I need to find the area underneath here. So here's what I'm going to do. I'm going to drop this down, drop this down, which gives me T1 here and T2 here, right? I'm going to make this spot right here V1, and this guy up here V2. Now don't draw this up. I don't need you to draw this up. I just need you to work with this. Okay, I want you to understand where these equations come from. So often in math and physics, we just tell you, here's the equation, use it. Law of cosines, law of sines, here. This is how it works, just use it, right? Okay, so today I'm going to try and show you where it comes from. So in order for me to find the displacement here, I could use the trapezoid. Does anybody know what the area of a trapezoid is? How do you find the area of a trapezoid?
Make it into a rectangle and then find their.
No, I want the area of the trapezoid. I'm already going to do that, but I want the area of the trapezoid. Does anybody know how to find the area of the trapezoid? Base 1 plus base 2 divided by 2 times the height. Right? It's the area of the trapezoid. But we're not going to. We're going to make this into a rectangle and a triangle. Okay? Which is what we just said. All right? So, this guy right here, this displacement is found by doing what?
T2 minus, no.
Yeah. How do I find the area of this?
T2 minus T1.
Which is change in time.
Yeah, multiply by V1.
Multiplied by V1. Exactly. So this guy right here is V1 delta T. Right? So he was right. Take your time 2 minus your time 1. You get that amount, right? Okay? And then times it by your constant velocity here. All right? Or your V1, sorry. Which is this height right here. So V1's the height of this. We all agree?
Yeah.
And then the change in time is the base. So T2 V1. Okay? So that's good. So now, how do I do it up here then?
Your change in time times by V2 divided by 2.
V2 divided by 2.
Like your change in time times by V2, and then you have to divide that by 2 because it's the drive.
Okay, you're very close. But you have an error here. Why do you say V2?
Between Z1 and V2 would not be.
Okay, so all
Oh,
right,
I
so
guess, yeah,
what is this,
Average
what is
velocity.
this base right here? What's that base?
V1.
What is it?
Big total.
This, from here to here. From there to there is how much?
Your total time
Not total.
Change in
change.
Change in time, I agree. So that's my change in time. What is this guy right here?
Change in velocity.
I'm changing my velocity. Okay? Alright, so far? And then I have to take a half of that. Agreed? So that is, this part right here would be d, 1/2, change in velocity times change in time. Agree so far? Everybody's okay? Alright? Change in velocity. The change in velocity, what is it equal to in terms of acceleration and time? So if I want to get change in velocity by itself, what's it equal to here?
Acceleration times change in time.
Acceleration times change in time. We all agree? That's what change in velocity is? Okay? So what I'm going to do then is I'm going to substitute that in for this guy right here. So the total distance right here, d, this is equation number 3, is equal to v1 delta t plus 1/2 a times t squared. Squared because I times it by this t as well. This is equation 3. That's the one you're going to use most often in everything that you do related to kinematics and physics.
So that would be velocity times change.
So this is velocity 1 times t. So if you know your initial velocity and the amount of time you're traveling for, add it to 1/2 your acceleration during that time times t squared. Okay? That is the guy that you're going to use most often. That's equation number 3. Number 4, we use infrequently, but we still use it. It's along the same lines. Again, it's just a substitution. So now number 4, you substitute in. You make it in a rectangle and then you subtract the area of the triangle. The long and short of it is this. So what they did here, let me show it to you. It doesn't matter. So they extend this like this, right? So they make a rectangle here. Okay, they make a rectangle. So what's the distance from here to here? Put your y value up here, v2. So it's v2 times time minus the area of this rectangle right here. So that is v is equal to v2 times delta t minus 1/2 a delta t squared. Like that. All right. Number 5 is another one of the more important ones because it's the one equation that you can use where you don't need time. And number 5 is v2 squared equals v1 squared plus 280. Right? Those are the 5 equations. Those are the 5 equations that you're going to use anytime you do work with kinematics. For those of you that we haven't talked about this already, you should have done it in grade 10. Kinematics is the study of motion. Alright? Let's look at some examples. Page 71. ball rolls down a hill with a constant acceleration of 2 meters per second squared. All right, so grade 11s. Grade 12s already know what I'm looking for. Grade 11s, here's how this works. I want you to write out all of the information that you get so that I can see it. That's half the battle right there. So 2 meters per second squared. The ball starts from rest. V1 is 0 meters per second. What is the velocity at the end of, so I'm looking for V2, at the end of, was it 10 seconds? 4 seconds. So there's what I have. That's the information given to me in the question. So now what you do is you have those 5 equations beside you. Those 5 equations are beside you. You shouldn't be writing on that sheet of 5 equations right now. I want them separate. I want them beside you so that you can look at them every time you do a question. Now look at that set of 5 equations and tell me which one has these 4 variables in it. Number 1 does. Because I'm looking for V2, I'm given V1, acceleration, and time. We all agree? So now all it's a case of a substitution. V2 equals 0 plus 2 times 4. Meters per second. Okay, so far? Here's the thing. You start from rest, and I want you to put this in a practical sense. You're starting from rest. For every 1 second, you're going 2 meters per second faster than you did before. Right? So after 1 second, how fast are you going? After 2 seconds, how fast are you going? After 3, and after 4, you're going. So I used an equation that I could practically think it through. Right? It's not necessary sometimes to use all the math equations to get to a solution. You can think it through without. But for me, I need to see the information in order to find out whether you know the question or not. Right? Okay, so there's A. What does B ask you to do? How far did the ball move? Now, I would rewrite this out, or just leave it and just say this. Okay, now I want D. I don't want to use this to solve, because if I made an error in A, I can't get B right. So I don't want to use a number already solved. I want to use the given information. So here's the given information. A, V1, time, and I'm looking for D. Which equation am I going to use? The third one. V1 delta T plus 1/2 A delta T squared. Good so far? What's V1? 0. So 0 times T is 0. So I don't even put it in there. 1/2 2 times 4 squared equals, how far did it go? 16 meters. All right? List the given information down the side and then use your formula sheet to pick the right equation to use. Got it? Any questions so far? All right. Take 1 minute and write down the given information from question 2. 1 minute and just write down the given information in question 2. Okay? How many pieces of information were given to you? How many? What was the first one? What?
V1.
What's V1? 0. Then? What's V2?
2 times 10 to the 7.
And? D, which is?
0.1.
How many of us got all that right? Who did not get it all right? Okay, what did you miss, Kelsey?
I put my information in the wrong spot, so V1 was a V2.
Right. Okay? Don't miss that word rest. That's an important one. You'll see that all the time. Something starts from rest. That means initially your velocity is 0. So that's important to you. Okay, so there we have it. Now what's the first thing it asks for? Find the acceleration. So which equation deals with no time? The fifth one. So I've got v2 squared equals v1 squared plus 2at. Okay, so here's where the math skills come in. You may, if you choose to, put the numbers in now and solve for the numbers. That makes it easier. Right now I want to work with variables because I think the more important thing is, can we manipulate the variables in this equation? I want to solve for a as it's written. What's the first thing I need to do to get a by itself?
Divide.
Divide by b.
When do you ever divide first?
You subtract it
What am I going to subtract?
to a,
Nope.
or just
The
v1 squared.
v1 squared needs to be subtracted first. You always start with add and subtract, and then divide is always the last thing, right? So, what do I get? I've got v2 squared minus v1 squared equals, right? So now that I got this on this side, what's the next step? Divide by
divide by 2.
2d, right? And that's equal to a. Fair enough? Okay, so now you put your numbers in. Now, I'm doing this to help you remember how to solve equations for unknowns. But I would have done this. Okay, I know that's 0, right? v1 0. So all I have to do is go 2 times 10 to the 7 is equal to 2a times 0.1. So I just need to take 2 times 10 to the 7 and divide it by 2 times 0.1. You need to use brackets when you do that. So everybody punch it into your calculator right now. Punch it into your calculator. 2. Oh, here's another thing. We'll talk about this. We do it in grade 10. How do I type this into my calculator? I don't type it as 2 times 10 to the power of something. What do I use?
The button below the 10x button.
Nope. Nope. You don't even have that. Which is it?
It's the like the triangle.
No, it's not the hat. What do I use instead? What do I use instead?
Log, it's like second function log. That is 2.
Nope.
The E,
Yep.
the EX,
What is it?
the EX,
Not e to the x either.
E, the EE,
The EE. So on this calculator, it's the EE button. So 10 exponent 7. And it should be divided by 2 times 0.10 equals your A. So if you do not have the EE button, you should have an exponent button on your calculator.
that's it.
That's it, yeah. You have an exponent button right there. It means the same thing.
Different the times or you just put EE and then 10?
No. Okay, good question. Do you have to put the multiplication in? No. All you do, this E value here, exponent value means times 10 to the power of. So I just go 2e7. That's all I do. Okay? You got it? Two. You know what you do?
How does it know it's 10, but it's
No, because I don't want times 10 to the power of. I just want 2e7. And then you got it right. Bodie, you good?
You gotta make
You're
calculator.
just in the other partner too. Okay, well, just sit tight for now. Those of you that don't have your calculators, sit tight and then go get them after we're done. Okay, so, yep. Well, except I don't need brackets. You can put brackets, but you don't need brackets up there. You need brackets on the bottom here. So I need to know what everybody got here so we can make sure that we use the calculators properly, because this is huge. So who's got an answer for
100 million.
Marshall?
I got a 12.
You got what?
I got 1.
Use it in a scientific notation, man. 1 times 10 to the power of what? 10 to the power of 9? Okay.
Yeah, 1 times 10 to the power of 8.
Yeah, that's what
Yeah,
I
that's
thought.
fine.
Yeah.
It's 8. Let me just see what you put in point.
Yeah.
No, the answer is 9. The answer is 9. Okay, so, yeah, listen, hold on. Just relax and listen here for a second. Okay? Because those of you using the graphing calculator right now, it's not putting it in scientific notation for you. So you're writing it up. But it can do it. So now go into mode at the very top. Go to mode at the very top. I wouldn't do this all the time. I'm doing it for this question to show you how to do it. And at the very top, you pick scientific notation. So now I go back, second function quit, hit enter on my answer. No. It was wrong. 1 to the 8 is what I got on hers. Everybody else get 1 to the 8?
Yeah.
Yeah.
Oh, I did 0.01. No, yeah, I did 0.01.
Okay, so everybody's got that. Who does not have that value on your calculator right now? I need to make sure. Okay, so I would put it back. I don't like scientific notation myself personally, so it's up to you. So you go mode. No, you don't have mode on this one. So yours is okay. So there's the other issue. Okay, so just using your calculator properly. That's what we gotta make sure. Any other questions about that? Anybody not get it still? All right. Okay, I need to make sure that's how it works. Okay, I'm done with this for right now because I need you to do some work today and then come back to it. So here's your list of pages that we're going to work on. Beginning back at the start from yesterday. You know what? I'm going way back here. So before we did yesterday, I want you to do the following. Write this down, please. Okay, here's your assignment. We work on that today and tomorrow.
Two texts, 400, 136.